Hello guys, welcome to our composites. This is Himanshu. Today we'll be diving into AddPath's unique feature, which is continuous winding on a cylindrical tank with dome. So that's why I've imported this cylindrical tank file along with this external axis. Let's just look into it. As you guys may previously know, I explained it to you like how to import the file from the system, how to explode a single geometry into different sub-geometries of the mold, how to align the mold with respect to any axis whichever you want. As you can see, we have mold connected to the E1 axis, which is this external axis. Now let's move ahead to the laminate definitions to plan the further laminate process. As you guys may already know, in our previous videos we used to select this planar mode, which is 2D and 3D open shapes. But for now we'll select this continuous winding cylindrical tank with dome, because we are working on a mode which is cylindrical tank who has a dome. Then just first select the cylindrical area where we want to do the layup on. Make sure the normal is on the outer side. Then the dome area. Make sure you cover all the dome area. Yeah, we're good to go. Now let's define the zero direction. Just move your cursor to this outer radius of the dome, from this center to this left dome center. Yes, and one line in perpendicular. Yeah, we have successfully defined zero direction. Now let's move it to the winding section, where we have to calculate the dimensions of this left dome, this right dome, and the middle section. Let's just first check the diameter of the left dome. Always go for the outer radius like this. Let me check this once, like this. Length from this center to the middle section center, just move the cursor to the middle section's time like outer boundary and it will automatically snap to the center. Now let's check the diameter of the middle section. Length of the middle section from this center to this center. Now the diameter of the right dome. Both the domes are identical, so it must be same. The length also from here to here. Yeah, you can see the length is also same. Now let's move it to the more options. The first circuit will start from the left middle section boundary. So as of now this option has been selected. So the first circuit will start, the first layup will start from this side. If I select from middle right section boundary, then it will start from this side. If I select like from extreme left, then it will start from the extreme left. Same goes for the extreme right option. And run for one circuit spin, like how much we want to do the layup on. Suppose I select 0 here, then it will do the full coverage of this mold, this middle section. Let it be 0 for now. The winding section direction is set to positive. You can even invert it and change it to negative if you want to, according to your desired needs. And winding mode is set to tape placement roller in contact with surface. As you guys can see, this is the roller, and this will be in contact with this mold surface during the layup. And if I just want to give it some kind of offset, like horizontal and vertical, I can choose this mode. And if I want to also modify some tape length, then you guys can also choose this mode. This is just for reference, like how to define the zero direction and how to like calculate the middle section, the right dome and the left dome. Let's just go to the layer parameters and define apply, close all and plan all. As you can see, the planning is being done. The frames are generating. Planning complete. Let's go to the simulate section. play. I'll just increase the animation speed a bit. As we can see, because we have selected the zero circuit, the full coverage is being done, and we have also selected like roller in contact with the surface, so that's why the roller is in contact with the surface. This is how we do the layup on a cylindrical dome. So yeah, if you guys enjoyed the session, make sure to like and subscribe. Thank you guys. Hope you have a good day.